which means my roots have to be imaginary. You did not have to get the I on this understanding check to get full credit. We let it slide here because we hadn't covered it very much. But you should look at that graph and quickly realize, hey, that's an imaginary root. Or not just an imaginary root. Does anyone know why I said it's not just an imaginary root?
It's a root there, we just can't see.
Well, that's why it's imaginary. Huh?
There's 2 roots.
Why is it 2 roots? It's a parabola, a quadratic. A quadratic always has how many roots? 2, right? So both of my roots would have to be imaginary, okay? So I will point this out. You cannot factor it and solve it via factoring. You can use vertex form. Does anyone know the other method you could have done? Quadratic formula. When the roots are imaginary, you can only use the quadratic formula or vertex form. But from here, how would I solve? So I'm going to make that 0. X minus 2 squared equals -1. Now, take that square root. Notice, when I take that square root, we now know this very well, hopefully. The square root of -1 is I. Alright, good to go so far? Add 2 to both sides? Uh-oh. What's wrong? What's wrong? Liam, what did you just say earlier about the number of roots? It should be 2 of them. How many do I have right now?
It's a double root.
It's not a double root. A double root can only exist when you intersect the x-axis and it's touching the x-axis, but good thought. Not x plus 2 and x minus 2, closer. When do I get plus and minus? When I take the square root. So it should have been plus or minus I. When I took the square root here, right, I should have had plus I and minus I. So really it's 2 plus or minus I. So you can write that as 2 plus I and 2 minus I. So either this or this would have been acceptable. Or would be correct. What are your questions, comments, or concerns at this point? Did we learn from our mistakes?
Yes, sir.
Feel better prepared for a test, Sheridan? You kind of say, eh? Do you still have a question? Okay. If you think of a question later and want to come in during enrichment and ask, or come to any of the tutoring sessions and ask, or just email me later, let me know. That's right. Jaquan, you never responded to my email this weekend. He emailed me, so I responded. So let's get started with today. We're going back to lesson 6 to wrap up activity 6.3. We should be able to get through activity 6.3 and 6.4. We talked about this number 1 yesterday. I believe it was page 102 maybe. 100, thank you. Okay. So, one thing I do want you to remember is it's okay to make mistakes, especially on understanding checks, is a check on your understanding so that you can learn and grow before the test. You can make it a 10 on an understanding check, you make 100 on the test, and your understanding check becomes 100. I don't care when you learn it, I care that you learn it. So learn from your mistakes and grow. Now, here on activity 6.3, this is where we left off yesterday. What do we have to remember when graphing on the complex plane? The imaginary number is your y-axis, and the real is the x-axis, right? So when I look over here at h, Well, square root of negative 1, what's that again? I. So I get negative 3I plus 3. So how would I graph that point?
You said negative I plus 3.
Negative 3I plus 3.
Left 3. I mean, yeah, left 3.
Is it left 3?
Yeah.
Negative 3I down.
So remember, and you're thinking left probably KT because we usually did left and right first, but remember we just said that the imaginary is the y, right? So negative 3 is down 3, and then to the right 3 because the real is positive. Okay? So that's it for graphing. Don't make it more complicated than that. So I wrote it as the original, by the way, but that is negative 3I plus 3. So we should have had several of those from yesterday. Parts of activity 6.3 we're going to do together because the practice comes in on activity 6.4. But I want you to note in number 3, we didn't start 3 yesterday, did we?
No.
Okay. Suppose you start at the point negative 5 plus I. So to the left 5 plus I is up 1. Notice we're no longer starting at 0, 0. Before I graph though, I want you to think about, take 30 seconds and make a prediction about how we're going to start at negative 5 plus I and add 2 plus 3I. So I want you to take 30 seconds, think about how are we going to add those two numbers together. Just thinking. Okay, so what's your prediction about how we're going to do negative 5 plus I and add 2 plus 3I?
I mean, the most common thought is going.
Let's let Caleb think out loud first, then we can hear other ideas.
The most common thought is going right from negative 5, go right 2, and then on the y-axis, go up 3 more.
Okay, so you're looking at it graphically. What do y'all think about that idea of right 2 and then up 3? Okay, so if I go to the right 2, so right 2 and then up 3, I end up here at negative 3 plus 4I, right? So yeah, negative 3 up 4. But my other question would be this. How could I take negative 5 plus I and get 2 and use 2 plus 3I if I'm adding those together and get that same negative 3 plus 4I? Anybody have a prediction?
Could you get,
Oh yeah, what is negative 5 plus 2?
negative 3.
Negative 3. So I plus 3I would be
4I. So that's all it was.
Is that what we see graphically as well? So we're going to add our, actually look at this next piece. Make sure you have that note down. We're going to look at number 4. I'm not going to stress about 3b. Make sure you have it graphically. Okay? So I might do that part where I underline like I did and circle like I did, because what am I showing? What goes together? Yeah, what's matching? Okay. Again, I would make this note graphically over there. on that coordinate system that's above, right? How we're adding 2 and 3i. So the note that we have in number 3, or 4, sorry, I believe it's on the next page. Kimani said to add two complex numbers, you can add their real parts separately, then add their imaginary parts separately, and then combine the results into the form a plus bi. Is that true? Do we add the reals and add the imaginaries? Yeah. So I'm not going to stress about explaining why, but I want you to note to yourself that this is true. Right? This is what you want to think about when to add two complex numbers. This is how you're going to do it. That's it. To add two complex, you're going to add the what? You're going to add their real parts and add their imaginary parts. That's it. Don't make it more complicated. Now number 5 is slightly different. What's different about number 5? We're what? We're subtracting. So let's look at it graphically. We're going to start at what number this time around? What number are we starting at in number 5? Negative 3 plus 4i. Okay, so that's where we're starting. Negative 3 plus 4i. And then we are subtracting negative 5 plus I. Say again. So remember, it's a little bit more complicated than just going left or right. But what is this note here about remembering? Subtracting a number is adding its negative. So instead of thinking about it as subtracting negative 5 plus I, how could I rewrite that as adding? Adding what? Remember, you're subtracting a negative. So you could be adding 5. Think about if you were to distribute that negative, right? So that would end up being a positive 5. So you would add 5 and then what? So then you'd be subtracting I. You're just distributing that negative throughout so that you end up just adding. Subtracting is the same thing as adding, the opposite. So this means to subtract negative 5 plus I, negative 3 plus 4i minus this gives me negative 3 plus 4i plus that. So graphically, I'm going to go to the right, 1, 2, how far? 5, and then, so right here I'm done? So just to the right 5? Remember, this is what I'm, it's minus, so it's down 1, right? So, plus 5 minus 1, we are adding a negative, right? So we're going to rewrite that subtraction there as adding a negative. And so we get back to 2 plus 3i. So the question is negative 3 plus 4i minus a negative 5 plus I equal to 2 plus 3i? Yes. Yes. We can see that graphically. But I'm going to go ahead and tell you this. I am never going to add or subtract complex numbers graphically. What would have been easier than doing this? What could I have done?
Distribute.
Be careful. You say distribute. When do we use distribution? Say, Chloe? With multiplication. Right? So here we could distribute because we're distributing that negative 1. Because we're multiplying, right? But here I'm just literally adding. What did we do, or what did we say just a second ago about adding?
Same thing.
Hold on. Wasn't Marquia talking? She's right next to you. What are you saying, Marquia?
I was saying adding the real and
Is that true? We would add the reals and add the imaginaries? Okay. So negative 3, and I usually would group them together that way. Negative 3 plus 5 plus 4i plus what? already got the 5.
Oh,
Remember, I'm grouping my reals together. Now I'm putting my imaginaries together.
A 3.
Plus a negative I. Jump in, KT, slow down. Negative 3 plus 5? 2. Whew. What class are we in? Algebra 2? Struggling with that negative 3 plus 5? Come on, guys. And what's 4I plus a negative I? 3I. Is that what we saw graphically?
Yes.
Okay, so you can do that distribution of the negative. I will point out personally, adding the negative only is really helpful on the graph. I'm just going to subtract 4I minus a negative 5 minus I. That's literally what I would do. And then I'd probably group my like terms, maybe just by underlining or showing this. Same exact answer. So the big thing is when adding and subtracting, you add and subtract the what? The reals, and then you add and subtract the imaginaries. That's it. You add and subtract the reals, you add and subtract the imaginaries. Okay, that's it. Questions, comments, or concerns? Okay. You'll notice we skipped the second part of that, and we'll skip the second part of this number 5 because it doesn't change much to your learning. It doesn't add to it, at least with the priorities that we have. So we're not going to skip 6. Number 7. So we want to notice what we've done so far is that we have either added or subtracted. What else do you think we're going to do? Multiply. That's what they're talking about here. I want y'all to read this detail up here. Does anyone see an important word that we should be thinking about or noting about that multiplication? Oh, when we multiply, it's going to what? Dilate, meaning it's going to stretch or compress. Those ideas have not gone away. They will continuously come up throughout any mathematics you study. For example, we have 1 plus 2i given right here. How does 1 plus 2i become that 2 plus 4i? We're multiplying by something. 2. Multiply by 2. So we stretched it by a factor of 2. So 2 times 1 plus 2i, is that going to be 2 plus 4i?
Yes, sir.
Anybody have a question about how we got there?
Yes.
Yes, you have a question?
What's the question, sir?
What?
You said it one time.
So what y'all were saying is that in order to get that 2 plus 4i, I multiplied 1 plus 2i times 2. 2 times 1 is 2. 2 times 2i is 4i. So we dilated, we stretched by a factor of 2. Okay? So what would I need to do to 2 plus 4i to get 1 plus 2i? Multiply by what?
1/2.
Ooh, say that word again. Oh, we are going to compress. That's not what I thought you said. But yes, what? Okay, divide by 2, but I like the multiplying by 1/2, right? Because it is multiplication. So this is 1, what's that fraction bar again? Divided by 2. I want to point this out. Okay, so yes, it's a compression, but also I want you to notice, didn't we just go backwards? So 1 plus 2i to 2 plus 4i. Now 2 plus 4i to 1 plus 2i. Does anyone know another term that could relate these two numbers? Not just any old inverses. Multiplicative inverses. What's the name for a multiplicative inverse, by the way? Reciprocal. We want to know that's a reciprocal. So to go backwards, we wanted the multiplicative inverse. We wanted the reciprocal there. Now that's not a huge priority here. I just want you to see that connection. And again, don't forget, activity 6.3 is to help us start to see ideas. Activity 6.4 is where we really start to practice them. But you can refer back to this later. Okay, C. Anybody have an idea what we could multiply by to get 5 minus 5/3 I? 5 divided by 3? How'd you get that? Hey, Caleb, is your name Sheridan? I appreciate you wanting to get involved. I want you to be involved, guys. But when someone else is saying stuff, be respectful of them. So Sheridan, what were you saying?
I just saw 5 divided by 3.
So you saw this was a -1 and then it became 5 divided by 3?
Yes.
And I want you to think about this. If I take the number 3 and I divide it by 3, what do I get? 1. And then what's 1 times that 5? Right. So we made that 3 become a 1 as well and then multiplied it by 5. Questions, comments, or concerns? Hey Zeus, come on now. Okay. I know you're not sleeping on me. All right. So what about D? How would I go from 5 minus 5/3 I back to 3 minus I? 3 divided by 5. Notice, what's the relationship between those two factors? Reciprocals. They're the multiplicative inverse. They will allow us to go backwards. We want to note those kind of things. But the priority that I want you to see is this. With number 8, what do these products suggest about the distributive property in complex numbers? What can we do with complex numbers? What have we been doing this whole time? We've been multiplying, say again. We've been distributing, haven't we? So can we distribute with complex numbers? Yes. That's what you want to notice here. When multiplying, with complex numbers, the distributive property works. A lot of times students try to use distributive property when it does not work. So it's important to notice that we can use the distributive property here. So when multiplying with complex numbers, the distributive property works. That is a critical piece of information. When multiplying with complex numbers, the distributive property works. You with all that, Jaquan? Jaquan's just like, Mr. Kenny, I'm excited because I only got like 5 more days with you. 5.5, I guess. You wish you did. You're gonna learn so much after the seniors are gone.
So Mr. Kenny, you gonna do it like that for real?
Please.
Y'all got 6 juniors in here. That's enough to learn. If I have 1 junior in here, you best believe I be teaching. Right in your face. Because my job is to teach. Alright. Yeah, third block is, well, I mean, you say it's nothing but juniors, but it's like 10 of them total, and yes, 8 of them are juniors. I got 10 juniors in my first block, so I ain't got any kind of break from teaching you, but yeah. I could, but do you know me?
He won't even let himself do that, won't feel right. He won't be able to sleep at night.
So, activity 6.4, this is where we're going to practice everything we just looked at.
Oh my God. Will sleep or
I just haven't gotten no sleep. Yeah, I see. Alright, so working within our small groups, I'm not going to give you any more instruction than this. Perform each operation and show your work. Pay attention, because I will remind you, when's the only time you can use the distributive property? When multiplying. If you're not multiplying, don't you dare distribute. Okay? So let's work with our small groups. Let's try to simplify these complex numbers. If you finish one before we come back to the whole group, move on to number 2.
Alright, man. You know, y'all didn't like him. Y'all ain't working out. It's gonna be on point.
I got my lunch.
Sounds like something else. You don't get no pass. Yeah, that's all. It's easier. Or will you get lost?
What you thinking about? Can we distribute for that? Do you agree that we distribute there, Tracy?
We are.
Are they multiplying? Are we multiplying?
Oh, no, we won't.
It's just subtract. Oh, I think it's right. We gotta pay attention. Remember, the distributor property only works with multiplying. We are subtracting, so you're gonna subtract which parts?
Hold on, let me see.
Like, are you gonna do 3 minus negative 6i?
Oh, we gotta input. Okay, no.
No,
We gotta put the real with the real, imaginary.
So, like terms kind of is usually when we're referring to algebra, but when you say like terms, tell me a pair that you mean like, you're thinking are like terms.
2i.
So notice what you would say is that the 2i and the 6i are the imaginary ones. The 3 and the 1 are the real ones. So you would subtract the reals and you would subtract the imaginary ones.
Do what I'm thinking, I don't know.
2i minus negative 6i.
2 minus 6.
Let me go get a 4.
I think you're forgetting one thing. Are you just subtracting 6i? No, you have 2i, and you're subtracting what?
That's all what you gotta have.
Not 6i.
That's all you gotta do?
You're subtracting a,
So we added.
well, yeah, but more, subtracting a negative 6i. Isn't it minus negative 6i?
I know, but it's not really the same thing you're saying.
If you subtracted negative, what do you have to end up doing? Add? Okay, right?
It would be 4i.
Minus 4i, that's what you got?
So 2i.
A and B.
Oh, just another I. Okay, so we got 5.
Come on, I'm not even.
3 minus 6.
I know what you said. I'm only. Wait.
So it would be minus
First off,
4.
what do you mean by combining like terms?
Probably.
You know what you're doing?
So,
I don't know either, I just can't know, but I'm kind of getting it.
I don't know.
Sorry, minus 4. I'm only using it.
Yes. You know how? Yeah, but it's not like terms. It's imaginary.
What you call?
How many i's is imaginary?
Yeah.
That's 4 i's.
Anyway.
You add those together, how many i's do you have?
Sorry.
Huh?
5 times 3. 15.
Well, so remember, the whole thing was that it was 3 minus 1, and it was plus, there's a positive 2i minus a negative 6i. When you do 2i minus a negative, you get a positive 8i, which means you are at 8.
I was here. And then 5 times negative 2 would be
You stuck on A?
or would you make that 11?
Do you think you got it?
Or is it?
It looks like y'all got some answers. Doesn't look like Sheridan's got it. Y'all checked it.
Yeah.
And if you 5 times
We should all be working together. What?
10.
That's impossible. I haven't been to a men's warehouse in about 5 years, 4 years.
Mr. King.
Online. I don't get them on from men's warehouse though, that's for sure.
I'm gonna just put 11 on. Cause on the last thing you just, when it was for I plus I, just
So remember we can graph them.
and I actually
Okay, no.
So what's happening? Put 10I squared. So even if it's 2I, it's just gonna be I.
And
Yeah, do this one and all the stuff about
I mean, do you have I times I? So do you have I squared?
I'm not saying this right. I'm just saying. So what?
Oh wait. It's multiple.
He said earlier when you imaginary with imaginary and real with real. Okay, 4I plus 1I is?
Minus 9. So it'll be minus 9. And then what would you combine? That's what I was asking. Like, are you practicing? Asking.
Just show me why you're doing it.
You know why I'm
Show me
saying
how you got the
I
number.
said that. I've been asking this the whole time. Y'all should have been listening.
Yeah, I should have said.
Okay, we have a question.
What's your question?
So if you like like two eyes drop each other, would it be squared or?
What's I times I?
Y'all didn't answer my question.
You did not ask me.
I did ask you.
Why you asking me?
What about super?
Okay, you in the dark.
I mean, like, I'm starting now.
So it's not. Okay, so that makes because y'all did this.
Preston, grab a seat.
No, y'all didn't. I asked.
Why are you asking?
We had 3 minus
So I'm getting there.
You need to show
Oh, okay, okay.
Jimmy John.
How much money you make?
Oh, I don't make any else.
Oh,
I'm